Let's talk a little bit about batteries and battery calculations. Time keeps the system alive. When the power fails, the clock starts ticking. The system doesn't just need voltage and current, it needs time. When AC fails, the batteries take over. The question isn't, does it run? It's how long can it keep on running? Batteries are rated in amp hours. That's amps times hours, a measure of how long they can supply current. Standby current is the quiet draw while the system watches. Alarm current is the short, heavy burst when the system needs to shout. The goal is to meet required runtime with margin. Amp hours equals amps times hours. A 7 amp hour battery can, in theory, deliver power in different ways. 7 amps for 1 hour, 3.5 amps for 2 hours, 14 amps for half an hour. It's the same math each time. Amp hours equals amps times hours. Real batteries fade faster under heavier load. Heat, age, and chemistry matter. Double the current, half the time. The math is simple. The system, not always. Let's talk about battery capacity in series and parallel. Two 12-volt, 7 amp hour batteries wired in series gives you 24 volts. The capacity is still 7 amp hour. Two 12-volt, 7 amp hour batteries wired in parallel gives you 12 volts. The capacity is 14 amp hours. Most fire alarm panels use two 12-volt batteries wired in series. Capacity equals the rating of one battery. Two 7 amp hour batteries in series equals 7 amp hours at 24 volts. Why this matters for TimeAlive. Battery calculations must be based on the installed configuration, the rated amp hour capacity, and standby and alarm duration requirements. Series increases voltage, it does not increase amp hours. Parallel systems. Some 12-volt combination Fireberg systems use parallel battery harnesses. Increased amp hour capacity, manufacturer listed configuration. Always calculate based on the listed setup. Watts tell you how hard it works. Amp and hours tell you how long it will last. Size batteries using manufacturer data and code required standby and alarm time, not generic textbook formulas. Round up, not down. When in doubt, go bigger. An example calculation. Say we've got a control panel with addressable loops and it draws something like 0.12 amps. Times 24 hours is 2.9 amp hours. That's our standby load. And we've got two NAC circuits at 1.2 amps each. That's 2.4 amps. Times 5 minutes of alarm. That's 0.083 hours. Gives us 0.2 amp hours. That's our alarm capacity. Our total capacity would be 3.1 amp hours. And we're going to add 20% margin to get us to the 3.7 amp hour battery. And then we're going to round up to the next available size battery. We add 20% to the total for margin, use 0.083 hours for 5 minutes of alarm, or 0.25 hours for 15 minutes. Most systems require 5 minutes alarm. Most voice systems require 15. The common battery sizes are usually 4 amp hour, 7, 12, 18, 26, 33, and 55, and they do go larger. Always round up to the next available size. Don't pick some random size that you're not going to be able to pick up at this local supply house. But also, don't round up too big where your power supply can't charge it. So you will have to verify that your power supply can charge whatever batteries you're using. NFPA 72 requires a minimum of 24 hours standby, followed by the required alarm operation. Non-voice systems, 5 minutes of alarm. Voice systems, 15 minutes of alarm. If it can't make that, it's not compliant. In best practices, we add 20% margin for battery age and heat. Replace every 3 to 5 years or when battery capacity drops below 80% of rated value. Some manufacturers set their own replacement schedule. Check it before you assume 3 to 5 years. Check charger voltage. Undercharge shortens life. Overcharge cooks the batteries. Label and date every battery change. Panels that work fine on AC can die quietly when the power is out. Never assume a system will survive just because it boots up. Test it, pull the plug, watch the voltage under load. Batteries give the system its endurance. Current times time equals amp hours. That's your required capacity. 24-hour standby plus alarm time equals code minimum. Always round up and verify with real measurements. Keep the push steady. Keep the time proven.